Welcome to this short video about bullet dynamic nuclear polarization, or bullet DNP. In this video we'll first explain how bullet DNP works, and then we'll show a few videos, a few clips on how this looks like in the lab, and then at the very end we'll show what we intend to do to accelerate the throughput of bullet DNP. So bullet dynamic nuclear polarization is very similar to dissolution dynamic nuclear polarization in that we start from a hyperpolarized solid where we have a very high nuclear spin polarization, and then what we want to do is we want to retain that nuclear spin polarization and record liquid state NMR spectra or images with a very high spin polarization. The key difference is that in dissolution DNP, we dissolve this hyperpolarized solid at or near the point of polarization, and then we transfer a liquid to the secondary device where we record data. In bullet DNP, we have the solid here, and we actually transfer the hyperpolarized solid over to the other system, and then we dissolve it only near the point of detection. This does have a few potential advantages. One advantage is that the transfer is very fast. You can transfer such a sample within less than 100 milliseconds from one magnet to the other using simply pressurized gas. The other advantage is that you can match your solvent volume here to your detector volume, and you can imagine that if you have a very small detector, you just melt the sample. So you don't suffer from dilution if you have mass-limited samples. There are also disadvantages, of course, potential disadvantages. So this transfer in the solid may bring about rapid relaxation. That is the key challenge that one has to overcome. And we do that by applying a magnetic field of approximately 70 millitesla at every position that the sample sees. So this is really important. So these solenoids go into the polarizing magnet, and they also go into the solution NMR instrument. The solenoid is energized with a current of 60 amps for approximately 1 second at 200 volts DC. And then once it's energized, the bullet is ejected, and it goes to this injection device here. And now Hannah will say a few words about how this device works.
The injection device is located in the target magnet. It ensures dissolution of the frozen hyperpolarized sample and injection of the hyperpolarized liquid into the NMR tube. It consists of 3 main parts: the solvent reservoir, the pinch valve, and the NMR tube assembly. Bullet loaded with the frozen hyperpolarized sample arrives via the magnetic tunnel and lands in the constriction in the lid of the solvent reservoir. Here the bullet is retained, but its content falls due to inertia into the solvent in the solvent reservoir. We typically use 500 to 700 microliters of the solvent. The solvent reservoir is pressurized. After some settling time, the pinch valve is open. The pinch valve connects the solvent reservoir with the NMR tube. Initially, the NMR tube is evacuated, but we also use pressurized helium gas to push the hyperpolarized liquid from the solvent reservoir into the NMR tube. When the hyperpolarized liquid is in the NMR tube, we apply pressure to redissolve and get rid of the bubbles. Then the NMR acquisition can start. After the NMR acquisition, bullet disposal program can be run that ejects the bullet from the device, and a cleaning program can be run that cleans and dries the device so that it is prepared for the next experiment.
For the experiment, we inject a solution containing the radical, the glassing agent, and the molecule of interest into the bullet, and then the solution is frozen in liquid nitrogen. Once the bullet is frozen, we can insert it into the DNP insert. For that we have a little airlock. So we can insert it into this junction here, close it off, and then evacuate it using a vacuum pump. And then once it's evacuated, we can drop it into the DNP insert, and then it's ready to be polarized. Once it's polarized, we just have a computer program which switches a couple of valves. Well, first we actually inject solvent into the solvent reservoir here with computer controlled syringes, and then we just trigger a sequence which switches a few valves and thereby ejects the sample. You can see the valve opening here in the video and closing again. The bullet is a consumable, and so if we want to increase the throughput of this method, we need a few bullets. And so here we show just briefly how we manufacture the bullet. This is this accelerated video. You can see that the bullets are machined, CNC machined from a PDF E-bar, which is here in the spindle. And at the end, a parting tool comes and cuts it off. And then you can see on the right, it falls into a container. And then a bar puller comes and pulls the bar out so that the next bullet can be machined.
The autoloader device is a system which is designed for automatic loading, freezing, and shooting the bullets that contain the sample. This overcomes the difficulties and possible errors of the manual loading. The autoloader consists of a linear actuator, Chitoni injection device, freezer part, and the liquid nitrogen lines. In the linear actuator, the produced empty bullet is placed in the desired location along a defined tube. Then, the bullet is precisely filled with the sample using Chitoni injection device. After that, we freeze the sample using a liquid nitrogen pump. At the end, the linear actuator moves and helium gas shoots the bullet into the DNP insert.